Hey, what's up everybody? My name is Moss, and in this video, I'm going to give you a recap of the second day of KubeCon 2024. In this series, I'll be providing summaries and key insights from the sessions that I attended at KubeCon, as well as interviews that I conducted with attendees and speakers. November 13th was the first day that they opened Solution Showcase. This was an area of the convention center where vendors set up booths and provided demos to attendees of the conference. A lot of the vendor booths had really cool stuff on display, and of course, there were plenty of gifts that the booths were giving out to attendees. I saw plenty of people carrying full tote bags full of merchandise that they had collected from various booths. But enough of all that, let's get into the session summaries. The first session that I want to talk about is the official OpenTelemetry project update. Now, there was a brief update given on OpenTelemetry during Observability Day. However, there was a dedicated session on November 13th, going in more depth. And one of the biggest updates that were discussed was the introduction of profiling as a new signal. The profiling specification and data model have successfully been merged into OTLP. And Elastic made a donation of their eBPF-based system-wide profiling agent. And you don't have to instrument your source code to utilize this profiling agent. The agent now integrates with the OpenTelemetry Collector, and it can provide profiling for a number of different languages, but also third-party applications as well, so you don't even need access to the source code. In parallel, there's ongoing work to implement native language-level profiling as well. And so the introduction of profiling as a signal in OpenTelemetry is definitely a big deal, and there was clearly a lot of excitement from users to utilize it. There were some other enhancements discussed as well. Logs are now stable with 2 logging paths for both structured and unstructured logs. In addition, there's new semantic conventions like messaging and database client, and ongoing work to stabilize the SDKs, APIs, and collector. The presenters then discussed the roadmap, and this included the declarative file-based configuration that's being implemented across multiple languages for a more simplified configuration experience. There was a dedicated session on file-based configuration on Observability Day, and it was clear that file-based configuration is an incredibly important feature if you're running in a complex environment, say with multiple microservices that are written in different languages. You can instrument all of those microservices using declarative language in a single file. They also talked about ongoing work to provide a control plane protocol, specifically the Open Agent Management Protocol. And this would allow you to manage and configure OpenTelemetry Collector instances at scale. And they also talked about work that they're doing to support client-side instrumentation for platforms like Android, Swift, and browsers. Android client-side instrumentation is currently in beta. And beyond the semantic conventions that I mentioned earlier, there are a number of conventions being discussed like CI/CD, Kubernetes, and much more. The next session that I want to discuss was about exemplars. Exemplars link metrics, traces, and logs. They enable more efficient troubleshooting and root cause analysis of your services. And OTTL provides exemplars by default. The creation of exemplars is built into the functionality of OTTL. Essentially, an exemplar is a high-value data point that is selected to provide additional context based on sampling policies you defined in the OTTL collector. And what I mean by a high-value data point is if you're looking at a metric in a dashboard, let's say it's latency for a particular service, and you notice that there are anomalies happening where there are certain data points that are much higher latency than the average data point value, that would be a high value data point where you would want to identify additional context like the trace and span ID of that data point. And with that additional context, you're able to get deep insights into those anomalies and more easily troubleshoot issues. And one thing that I'll point out here, and yes, I'm about to plug a Splunk product, is that you get this functionality by default in Splunk Observability Cloud. So if you're using the Splunk distribution of the OpenTelemetry Collector, there's a feature in Splunk Observability Cloud called Related Content. Real quickly, I just want to show what that related content looks like in Splunk Observability Cloud. So in the APM section, I'm looking at an environment that is my e-commerce website. And in the overview, you can see multiple time series charts. And if I hover over one of these charts, notice how it says click a data point to view related traces. And you can see this particular data point had very high latency. So if I select that, I get an in-context window showing related traces to that particular data point. And this trace ID is hyperlinked, so if I select it, it will take me to the trace. So from here, I can view the details of the trace, but what I want you to notice are the two related content windows that show up down here. So if I want to see log entries for this particular trace, I can just press the log window here, and then I can go directly to some log entries for that particular trace. And if I were to select the infrastructure related content window, it would take me directly to infrastructure resources that were related to that trace. And those related content windows show up in multiple places in Splunk Observability Cloud, like in the service map in APM, as well as the infrastructure management page. The final session that I attended was about the OpenTelemetry Transformation Language, which is a domain-specific language that allows you to modify and transform telemetry data before it reaches a backend. You can extract and parse unstructured log data, like converting raw JSON logs into structured attributes. And OTTL provides a simplified syntax as well as conditional logic that enables complex use cases. Although there were a lot of really useful functions that you could utilize with OTTL, one thing that stood out in particular was hierarchical data handling. OTTL reduces redundancy by associating shared metadata with resources rather than duplicating it. So for instance, let's say you have a series of data points, and each one of those data points has an attribute that is the Kubernetes cluster name. If a large number of those data points shares the same value, in other words, they come from the same Kubernetes cluster and have the same Kubernetes cluster name, then it's duplicative and redundant to include that data in each of those entries and send it over the wire. So with OTTL, you can actually filter that attribute and instead just make it a parent of multiple entries, essentially. That way, you're reducing the amount of data that you're sending over the wire and simply associating that metadata with multiple data points. I've linked the full recordings of the KubeCon sessions that I attended in the video description below. I hope you enjoyed this video, and if you did, we'd love to hear your feedback. And be sure to stay tuned for more session summaries as well as interviews I conducted with observability community members at KubeCon 2024. Thanks for watching.